Greetings, my fellow software test engineers, and welcome to the Software Test Automation Revealed YouTube channel, or STAR for short, hosted by me, Cody Gibson. This is episode 3, where we're going to cover page objects and Fluent Assertions. But first, would you please click that like and subscribe button, as well as the notification bell, so you will be notified as I upload new content to this channel. Thanks! So what is a page object? A page object is a class which deals with a specific page of your web application. So for every page you have in your web application, you should have a page object. You should have one for your login page, your home page, your feedback page, your about page, things like that. Your product pages, I would not recommend having a page object for every single product. That would be just unrealistically unmanageable. You should be able to, though, create one generic product page, because generally the format of the product page is the same. You're going to have the same footer, the same menu, the same headers, etc. What's going to change is just the content. So a common generic product page should be fine, so you don't have to have 100 or 1,000 different product page, one for each product that you would be selling on your website. But you do need to have a unique page object for each page that has a unique format, a unique layout to it, with unique web elements on it. Okay. The basic elements of a page object, you want to start off with your element definitions, such as page size. That's page size, in this case, represents the page size element at the bottom of our application, which, let's have a look at that real quick. That represents this page size element right down here. Okay. Then the other thing, whoops, wrong screen. The other thing we can have is Dinner's grid rows. Now notice, this is a list. This is an actual list of web elements, which represents each and every row in our web application. So it's going to be row, 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 row. It's going to grab all of the row elements in this particular page. And let's look at those a little more closely. Here we go. Now I'm doing the WebDriver. That's the link to the browser that we're currently automating. Doing a find elements by CSS selector. This CSS selector represents the ID. So this is the actual ID of that page size element. Now I'm deliberately doing find elements plural here, and then I'm going to deliberately take the .first or default. Now I'm doing this because the simple .find element singular, Selenium will do an implicit wait for that element. So if you look for the element's not there, Selenium's going to do an implicit wait, waiting for that element to exist and be on the page before it will return. So if you've got an implicit wait set for, let's say, 2 minutes, this could actually hang for 2 minutes waiting for that element to be found, versus a find elements does not wait. It simply grabs as many elements that are currently there and it will immediately return without waiting. And then I do a .first or default. So .first will give me the first element in the list. Generally with something like this, there's only going to be one element in the list, so it gives me the first one. However, if there are no elements in the list, then it'll return a default value, and in this case, the default value is going to be null. So if there are no elements, page size will actually return a value of null without throwing an exception, without waiting for 2 minutes. It's actually a much cleaner way of finding and interacting with elements on your web page. This one, I am still using the find elements plural. I don't have the .first or default because I want the entire list. I want all of them. Now that your elements are defined, you can now start using them in your methods. So here, I'm using page size to click on it. Then I'm getting dinner's grid rows. Same thing here, dinner grid rows. The rest of this code, I'll go over in more detail once we get to the code in Visual Studio. Okay, Fluent Assertions. Let's also talk about Fluent Assertions. To use it, you want to install the Fluent Assertions NuGet package. This is a NuGet package that I've kind of fallen in love with. I really love the way these Fluent Assertions work and are written, and they're also very, very extensible. I've already written a number of extensions that are very, very specific to web elements, such as web elements can be displayed, they can be visible. I've added extensions for that. Web elements also have classes, so I've got multiple extension methods for classes, class verification. They also have attributes. I've got Fluent Assertion extensions for attributes, their contents. So here's an example of a Fluent style assertion. I can say element.count should be something. I just love the way this reads and the way this flows versus the NUnit. In NUnit, they have the asserts. You can say assert dot equals, and then you have to pass it parameters. You can say assert dot is true, assert dot is false, assert dot is null, or assert dot is not null. I don't like that because it's much less obvious what's going on. It's much harder to read, and everything has to be passed in as parameter. Here, the element that you want to validate is not a parameter, it's the starting argument. So you know immediately what you're acting on, what you're verifying. The parameter is, well, this is what is your expected value. Now, the documentation for Fluent Assertions is here. You can actually see it. It's already very, very extensive, just right out of the gate. Let's have a quick peek at it. Your Fluent Assertions, this is the documentation. You have all kinds. And notice, with Fluent Assertions, you can even have multiple verifications on it. So you can actually say, in this case, it's using a string as a sample. I can say string should start with, and it should end with, and it should contain, and it should have a length. So this is really, really nice versus NUnit, you cannot chain them together like this. With NUnit, you have to do assert dot something, another assert dot something, then another assert dot something, versus chaining it together like this. And it's very, very, it's almost like an English statement. Makes it very, very readable, very understandable, fairly simple, straightforward. It's got all kinds of assertions built into it for dealing with strings, dealing with integers, floats, numbers, arrays, and so on. And you can even extend it with message and violations. There's just all kinds of things. It knows how to deal with dictionaries, generic objects, X documents. So you can look into this documentation on your own to better understand what all it is capable of. But for right now, all we're dealing with is just the very, very simple ones for right now. In this case, the element and the count should be some value. That's enough to get started with. All right, let's go and look at the actual code in Visual Studio. As I said, yes, you need to install the Fluent Assertions NuGet. So I've already done that in this package, and I will upload this with these changes to GitHub. So you can find this solution in GitHub right here. There's the path, and I'll provide the link to this solution in the description of this video, this YouTube video. All right, back to Visual Studio. So that's the NuGet. I've written a new test. So here's our new test for today's episode. I'm telling it, go to the dinner page, navigate to home page, change the page size, and notice it takes a parameter now. So I can tell it what page size I want to change it to. Then I also say verify current page size. Now notice verify does not need a parameter. It already knows what is the expected page size because it saved the page size in the change page size. So it knows, hey, you asked it to change to 5. It's going to save that value in the global data cache. And now it can say verify the actual page size equals what it was saved up here. And I just do that for all of the possible values. In our application, the page size can be one of 4 values. We can do 5, 10, or 20, or 50. So in my test, I'm switching to all 4 of them, and I'm verifying that the actual page size matched what I asked it to switch to. So let's take a look at how does these changes and verification actually work in the code. So the change page size method is right here. Takes an integer, what is my new page size? Okay, then I want to say page size.click. Now remember, page size is our element. So it tells Selenium, please go find this element, give it back to me, and then click on it. That's needed in order to change the page size. You have to click on this thing first before you can actually select one of these elements to change it. So then we're also capturing what is the old count. So before we actually change it, we want to capture what's the current page count. We need that because we have to wait until the number of grid rows actually changes. So right here, we're going to say find element. We have to use XPath in this case because we're going to find an element by text, which is the new size. The new size was an integer converted into a text here. So we want to find that element with the size number that we want, and we're going to click on it. That causes the grid size to change, but there is a delay. It's not instantaneous, so we actually need to wait for the number of grid rows to change, and that's what these two statements do. First, I say create a new wait object. This is out of the Selenium library. And I say timeout is going to be 1 second. So I'm going to wait a maximum of 1 second for the number of grid rows to actually change. Now I can say wait until I pass in driver, and then I say wait until the grid rows, the current grid rows count, does not equal the old count. This is the old count. Remember, I captured this before I changed it. So it's waiting for a maximum of 1 second for the number of rows to change. After 1 second, it just simply moves on. It doesn't throw an exception, doesn't stop the test. It will just simply continue. Okay, now I am capturing in my global data cache the expected page size. So I'm just storing in the global data cache the number that was passed in here. And that's why in the validation, I don't need to pass in a parameter for the validation. I can look it up right here out of the global data cache. All right, so that was for changing the page size, including all the parameters. Now I can do the verification. So let's look at the verification. That I have put into a separate file. I'm taking advantage of the partial classes. So with C#, you have the concept of a partial class. So you have 2 files that will compile to create one class together. Now I deliberately do this because I much prefer my elements and my action methods to be in one file, and then all of my validations to be in another file. This makes it much more modular, much easier to maintain. You can literally have 2 developers, one developer doing the verifications and merging that, and a second developer doing the actions and merging that. So you help to eliminate what's called merge conflicts when you're storing this in source code and you've got multiple people working on the same project at the same time, even the same classes. It makes maintenance better in the going forward because your validations are in one file, your actions are in another file. So let's look at this verification. Verify current page size. It's actually pretty simple, straightforward. We've kind of covered it already. You just simply say dinner page rows. Remember, that's an element definition from right here. That's this element definition. I'm getting back a list of web elements. I can look at the count. I can say should be, and right here I'm pulling that expected value from our model. And that model, let's look at that. That model is a new model I've added here. So it's just got one single element to it. Expected page size, stored it as an integer. So I'm pulling that expected page size out of my global data cache, and I'm verifying that the current data grid rows matches what is my expected size. So let's have a look and see this run. It's fairly quick, but it does run just fine. I have to wait for it to compile. Now it will launch the web browser. There we go. And going to the navigate page or the home page, resizes it, and now it's flipping through every possible page size. And that's it, really. Test is passed. So it's verified that all 4 page sizes work as expected. And that's how we handle page objects. That's how we take advantage of these Fluent assertions. Thanks for tuning in. So for next time, we're going to be looking at episode 4. We're going to be looking at logging test execution. I'm going to demonstrate a method how you can magically add automatic test logging without having to make explicit calls to the log. You're not going to have to say log dot something, log, you're not going to have explicit log statements sprinkled throughout your code. All right, that's going to be it. Once again, thanks for tuning in, and don't forget, click that like and subscribe button along with the notification bell so you'll be notified when I get episode 4 uploaded in approximately a week. Thanks again, and have a good day.